Hi, I'm Dr. B. Ravi Kumar, Associate Professor, Department of ECE, Institute of Aeronautical Engineering. So today, I'm going to discuss the tutorial bank questions for Module 2, which is nothing but Bipolar Junction Transistor. So in this talk, I'm going to give some explanation about how to give answers for a particular questions from Module 2. So for example, from Module 2, the most important problem regarding to H parameter model analysis of a given transistor amplifier. So that questions might be asked regarding to determine or design a C amplifier for a given parameter, H parameter model using exact analysis and approximate analysis. So in this talk, in this lecture, just I am giving an idea how to understand this problem and how to do a problem in the examination. So basically, this question, a C amplifier is drawn by a voltage source of internal resistance Rs is equal to 800 ohm and RL is equal to 1000 ohm. The H parameters are given. Basically, we know that in a C amplifier, C amplifier, this is the C common element configuration. So when we are providing proper biasings, RC, VCC, and RB, and the input signal is given, and we will measure some output in RB. So this simple kind of some amplifier will measure the output voltage by giving input voltage. So its equivalent H parameter model, we know that a resistor in series with the independent voltage source, and a current source in parallel with the output admittance. So in this is a common emitter terminal is common. So base is input, HIE, HOE into R, HFE into IB, HOE into, like in this case, V2 means here the output voltage, V2 means VCE, IB means IBE, HOE into output voltage. Here it is V2 VC, here it is VB. HOE, this one HOE into this output resistance. So now with here all the parameters of transistor H parameters, HOE, HIE, HOE, HFE, HRE, this one HRE, this one HOE. So these are all given. So now how to solve this problem? So determine the current gain, the input resistance, voltage gain, output resistance. These four important parameters need to be required to understand, analyze the of an amplifier. So determine the current gain, input impedance, output impedance, and voltage gain. So these parameters are helpful to design a particular amplifier. So in order to do that answer, we have formulas. Current gain, we derived this current gain minus HFE by HOE into RL, and input resistance RI is equal to, so once you find out by substituting the given parameter HFE plus 1 plus HOE into RL, so then that value is substituted into this second equation, input impedance, so that it will be helpful to get that answer easily. So RI is equal to HIE plus HRE into AI into RL. HI is given, input impedance is given, HRE reverse voltage gain is given, AI just now we found, and multiplied with the load resistor RL, you will get an input impedance. So that input resistance is substituted like AA is substitute and input impedance, input resistance is substitute in the voltage gain. AV is equal to A into RL divided by RI, so that you will get a voltage gain. Then, so in order to do this output impedance, first you have to do delta H, okay, determinant after H, all the H parameters, 4 H parameters, like H, HIE, HRE, HFE, HOE. So det, find the det cross multiplication of these two, then you will get a delta H. Then in that problem, source resistance is given, input impedance is given, and R is already given, HOE output admittance given, plus delta H just now we found. By substituting this one, you will get a output admittance or output impedance R naught. So here, what is this RIS means? Basically, in that problem, some problems given the consider the base resistance. So in this base resistance also consider. If sometimes the problem has not given that base resistance. If the problem has not given base resistance, that input resistance with the source is equal to Ri only. So RIS is equal to Ri. If base resistance is given, once you find this Ri, it is parallel combination with the RB, then that result like a input impedance including source. So RIS. So then we will get that current gain, input impedance, output impedance, and voltage gain will get. Then we will see the next problem. Transistor has IE is equal to emitter current is equal to 10 milliampere, alpha is equal to 0.98. Determine the value of IC and IB. Basically, in that given problem, it has given IE and alpha. We know that it is alpha is a current gain in alpha is equal to IC by E, common base current gain. Basically, alpha is equal to common base current gain. So alpha is equal to IC by IE, but is the problem given left side alpha parameter and right side IE parameter. So you have to find out IC is equal to alpha into IE. So then we find IC. So once we know the IC, already IE is given. So there is a relation in the transistor. Total current, emitter current IE is equal to IB plus IC. So IC already we just now found, and IE is already given 10 milliampere. So if you want to find out IB, IE minus IC. So this is actually the basic relation among the three currents, and there are different relationship between alpha, beta, gamma. Also for this kind of problems, we have used this kind of relations. Current gain, common emitter current gain IC by E, and IC by IB, common emitter configuration, and gamma is equal to IE by IB. So these are the relations, and also some same problems related to relation between alpha, beta, gamma. Alpha is equal to beta by 1 plus beta. Beta is equal to alpha by 1 minus alpha, like that. So we will get some answers. Alpha is equal to 1 by gamma is equal to 1 by 1 minus alpha, like that. So we will give which is equal to 1 plus beta. So these are all the relations. By substituting proper relations, you will get the different answers. And then the next question, determine the common base configuration collector current. Basically, there are each and every configuration having output currents. So in the common base configuration, basically this is a common base connection. Base is connected to ground, emitter is input, and the collector is output. So this common base configuration, the output current is nothing but IC is equal to IC majority, IC minority plus IC minority. Majority current is in the common base alpha IE plus IC B0. This is the collector current. If it is a common emitter, IC is equal to beta IB plus 1 plus beta times of IC B0 or IE0 first, that will replace with. In a common emitter, ICE0. This IC0 can be written as IC1 plus I beta 1 plus beta into ICB0, like that. So here the majority current alpha, that alpha is given 0.98 into I is given G3 into 10 to the power of minus 3 plus collector to base current when emitter is open. So ICB0 means collector to base current when emitter is open. So that will 10 to the power of minus 6. By substituting these parameters, we will get this one. Next, for the question, demonstrate the working of transistor in common emitter configuration and draw its input and output characteristics. Demonstrate the working of transistor in common emitter configuration. So this kind of question is most important from this module 2. So in this case, we have to draw with the neat diagram of configuration. Basically, configuration of a transistor means if you want to connect in any network, if you want to connect a transistor in any network, you must follow 3 configurations. One is common emitter, common base, and a common collector configurations. By connecting any one of these configuration, then we have to apply the analysis. So in order to analyze a transistor, you must have a connector among these configurations. So that's why this type of question. So draw the any configuration, whether it is common emitter or common base and common collector, and observe its behavior at the input side, input characteristics, and output characteristics. Now let us see simple circuit diagram, and it's how to remember that input and output characteristics. If you see this one, common emitter configuration, you must the emitter is connected to ground and input is connected to base. So we are providing supply. Input must be forward bias. So it is for example NPN transistor. P is connected to plus, N is connected to minus. Is input loop. Then it is collected to. You have to connect this one. If you want to measure output voltage, we use output voltage. If you want to measure the current, we connect milliampere or microampere, and then take the load resistor and supply voltage. So in order to connect the reverse bias at output side, we use plus minus battery. So we use ammeter. Here it is, we connect a voltmeter, and we use ammeter to measure the input current and input voltage. Basically, it is a base current, we use milliammeter and a voltmeter. So this VBB, VCC. So this is for common emitter configuration, for example. If you replace with that transistor with the base is connected to ground, common base, collector is connected to ground, common collector configuration. These two cases, then we need to draw the input and output characteristics. the output to this is input. It is a graph. It is input characteristics. So it is a general definition of graph. The general definition of input characteristic is a plot between input current and input voltage. Input voltage and input current by keeping output voltage constant. Output characteristics is a graph between output voltage, output current, input current is constant. By remembering this definition, we can apply to all three configurations. So you have to take this definition for any configuration. Let us take common emitter configuration. In this case, input current is a base. So it is a base means base current. So you have to take base current. You have to have base to emitter voltage, VBE. So take the VBE. And output voltage is constant means here it is output voltage is so we can measure VCE. So this was we can take like output voltage constant means VCE is equal to which varies from 2, 4, 6 like this. So basically the graph will get like this. So by keeping output voltage VCE constant with 2 volts, 4 volts, 6 volts like that. By measuring by small suitable steps increasing the input voltage, you will measure the input current. Similarly, by keeping input current constant, like here it is IB, like 10 microampere, 20 microampere. Then by changing the output voltage VCE, output current is IC in milliampere. So we'll get some graphs like this. So you have to draw this kind of graphs. In this graph, you have to mention must mention that 3 regions. So these regions are saturation region, and this region is called active region. This is called cutoff region. So you have to mention circuit diagram. First thing is circuit diagram. Second thing is you have to draw input and output characteristics and explain what is the behavior of the common emitter configuration in input side and output characteristics. And draw the small signal model of common emitter BJT amplifier, derive the expression, voltage gain and input resistance and output resistance. So for this kind of questions, you have to draw the small signal H parameter model. The small signal H parameter model is a general diagram is always follow this. So basically H parameter model V1 I2 equal to H11 I1 plus H12 V2, H21 I1 plus H22 V2. So in this case, this is like a KVL of voltage law. This is like KCL. So in order to represent this KVL, it look like a series network with H parameter values are HIE. So this is generalized representation H11. We can take HIE, we can take HRE, HFE, HY. So we take that one KVL law, we will give this one. V1 is equal to I1 H like I1. In that based on the configuration, that current voltages are changes. If it is common emitter, the input current is base HIE, HRE, VCE, like it is a voltage source. And due to this second equation, I2 is equal to HFE plus HFE I1 plus HY V2 means in this case for the common emitter, that these two equations are becomes like for common emitter V1 with nothing but VB is equal to IB HIE, HIE, HRE, HOE, HFE, HOE, IB, VCE, IB, VCE. Here I do nothing but IC. So this is HFE, IB, and in parallel with the HY. It is IC current, it is VC voltage source. So it is ground. This is common emitter configuration, common emitter model. So if you replace with the second subscript to B, it will become as a common base with the same diagram. It will replace with that common base configuration. And if you use the common collector, that second H parameter second subscript is C value. So if you draw the diagram for each and the common base, common emitter, common collector amplifier, then derive the voltage current gain, input impedance, voltage gain, output admittance. You have derived based on the given amplifier. If it is the question is draw the small signal model of common emitter, you have to draw this. Common base, the parameter just changes, the diagram is same. And then derive the equations by applying the analysis. So this is the way we have to write the questions in the examination. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.